So thank you very much, everybody. It's a great pleasure to be here. As you can see, I'm not alone. I'm here with Marcel Chuk. Alessandro Giusti is also here. So if you have questions about the grouping we will show or about the vision algorithm we will show, you can go to them and ask as many questions as you want. So I'm here to represent FEMTOprint. So FEMTOprint is a company that is building micro devices in glasses. They have a lot of innovative technologies that allow them to create new products in a very rapid way, to do fast prototyping, and to bring products very fast to the market. So that's great. But of course, when it comes to automation, that's a problem. Because they have a lot of different products, they have small production volumes, and they are like putting new products in the market every time. So how can they really find a solution to automate these tasks with a lower added value, but still be flexible enough? And the goal of this project was actually to create a solution that they can reprogram themselves, so that a non-robotic expert can reprogram themselves, so that they can very rapidly adapt the automation solution to their needs. So the task we have chosen is this one. So we have like finger clocks that are splattered in a containers. They are overlapping, and they need to be put on a plate with a very precise orientation for quality control. So it's a very repetitive task, no added value, but it takes a lot of time because it's difficult because the pieces are so small. So what we decided to do is to take a learning from demonstration approach. It means that the worker can use the regular tool he's using to show the robot what he needs to do. But for that, of course, we also need vision. We need to localize the pieces, and we also need a robust gripping system. And that's why we teamed up with No-Touch Robotics. It's a startup that is focusing on micro-griping and handling, and they are working with different technologies, such as contactless manipulation using acoustic levitation, adhesion gripper using liquid surface tension, and closed-loop vacuum gripper, which is the technology we will use in this project. And they can handle a lot of different types of products with that. So for the vision, what we had a micro-view microscope. That's the technology they had at FEMTOprint. The goal was to use what they already have. And with that, we can change the focal point of the image. And with this information, we can get information about the depth. So with that, we combine template matching to localize the pieces and use this depth information to create a point cloud to better to know which pieces to take first, so the pieces that is on top. For the gripping, we used a closed-loop micro-gripper, and with this closed-loop, we had the needed stability, because since the pieces are so small, they tend to move when we place them. We could use low forces, and there were no residue on the pieces. Then we used a network-sys camera and pieces with a tracker just to get a setup so that we can record what the operator is doing. We used the intuitive interface developed by the spin-off AutoMate Robotics to manage the point and to define the tasks. And then we filter it and send it to the robots. And with all these parts, we were able actually to have a system where, as you see here in the corner, a user can really show the trajectory. So in this case, it's point-to-point, but it could be a roll trajectory. And we record all the points, and then we can create a program that we will send to the robot so that the robot can execute the task. And even though the pieces are really small, we could very rapidly program this task. It took us less than half a day to just reprogram the whole system in a reliable way. So of course, we still need improvement, but the company was very happy with that. And now we are thinking about how, if we want to do an HuCE or another way, to actually extend these activities to more objects, more tasks, and more applications. Thank you very much, and we are around here if you have questions. Thank you.